So this is my video on how to find the domain and the range of a function from the graph. So we know that a function can be represented in several ways, like a table or a pair of ordered pairs or an equation or more visually as a graph. So when you have a function as a graph, how would you find the domain and the range? Stuff like that. Okay. So first of all, what is a domain? Domain is all legal set all possible input values for x. Okay, so x means so this is the graph that we have. So look at it carefully. So when you say x, we are talking about the horizontal axis, right? The x-axis. So we want to find the domain. We'll go from the leftmost corner of the graph to the rightmost corner. Right now, remember this graph will extend downwards to infinity, right? And we will look to see whether every element is mapped. So if you start from, imagine a kind of a very small number, negative infinity, you can surely this will be mapped to somewhere. And same way, so any large number will also be mapped. So we don't have any problems at the left hand or the right hand. But when we start moving, we are still okay here. Everything is mapped. Everything is mapped. But when you come up to negative 3, we have a problem. There is a point -3, -6. You can see like an empty hole there, which means -3 is not mapped. So we can say -3 is not in domain. Make a note of that, and we keep moving on. Everything else is mapped, again mapped. And this is also the question about 0. Is it mapped? Yeah, because 0 is mapped to this point 3, and there's a shaded like over there, right? And so now if you go to 1, 2, and then again we can see 3, right? And then we look for that point again, but this time it is mapped because now 3, 6 is actually shaded. The oval is shaded. Here the oval is empty, here the oval is shaded. So 3 is in the domain. So this goes on, so no matter, then you keep going to the right, okay, and every element, every x is mapped. So the only time we see x value not being mapped is here at -3. So the domain we can say then is all real numbers except -3. Or in interval notation, if you want to write this, you can say from negative infinity all the way up to -3 is okay, but we have parentheses to show that -3 is not okay. And then after we skip -3 and then we start again with -3 but with an open parenthesis to show that it is not included, and you can go all the way to positive infinity. So that's how you write it in the interval notation. Now let's try to look at to find function values. So if you want to find f of zeros, you look at the input 0, which means x is 0. Input is x, so x is 0 here. And you want a function value, means you want the y value. So 1, 2, 3. That will be 3. And if you want to find f of 3, then we go to the input 1, 2, 3, and we look at the function value, and we know that that function value is -3, 3, -6. So it is -6 because this point here is symmetric with this, and it's 3, -6. Finally, let us find the range. So the range is all possible y values. In other words, y values that are actually hit by an x value. So what you do is now, instead of looking like that, we try to looking like this. We start from negative infinity and to c. So this is hit, right? Okay, and so this is hit by an x values. Actually, it's hit by this y value, for example, is hit by two x values, this one and that one. That is fine, right? Go to this y, hit, no problem, hit by two x values. Now, let's pause at -6. Is -6 been hit by an x value? -6. Well, if you go to the left of -6, -3 does not hit -6 because there is a oval here, empty oval. But if you go to the right side, then you see that +3 does hit -c because there is a shaded over there, right? So -3, -6, even though it's there, it's an empty oval. It's not shaded. So what can you say then? Well, 3 does hit -6. Because 3 hits -6, -6 is in the domain. And then you just keep on up, and every time you go, you can see all the numbers up to 3 are in the domain. And 3 is also hit by what? 0, because this point is 0, 3. So 3 is also in the domain, in the range. So all the numbers are in the range, and 3 is also in the range. But now the question is, what happens after 3? After 3. So after 3, for example, if you take something like 4, there is no graph here. So in other words, there is nothing to hit 4. In other words, there is no x coordinate so that there's a y coordinate of 4. It stops at 4. There's nothing. So when you keep an eye, right, you can see every level is hit by an x coordinate, right? Okay, including 0. But after 3, it doesn't hit. Okay, so then we know the range. Everything up to 3 is being hit, but after 3 is not being hit. So the range will be all real numbers less than or equal to 3, because it was only up to 3. And if you want to write it in interval notation, it's negative infinity, because now you're looking through like that, okay? Negative infinity all the way to 3. That's it for this video. Thank you for watching.